So literally, this poster highlights the process of solving a water tank design problem. The key issues include the need to increase the tank's volume by 10 to 20% while maintaining a height tolerance of 0.3 meters, ensuring proper weight distribution for loads between 30 kN and 40 kN, adhering to cost and time limitations, and ensuring the structural integrity of the design for safe operations. The proposed ideas focus on addressing this challenge by considering volume and height constraints, weight distribution, and practical engineering analysis using tools like MATLAB and frameworks such as CDIO, conceive, design, implement, and operate. The solutions include applying engineering statistics to calculate and optimize the weight distribution on supporting beams, using MATLAB for volume analysis and determining the optimal tank dimensions, and creating shear force and bending moment diagrams to ensure the structural safety. So, the process is divided into 4 stages, which is the first one is conceiving the design through brainstorming and research, and the second one, developing detailed calculations and plans. And the third one is the implementing the design through practical testing. And last but not least, by ensuring operational efficiency by addressing maintenance requirements for the water tank design problems. A timeline is already outlined, starting from brainstorming on 5th January to the project submissions on 19th January. Roles are distributed among team members to handle specific tasks such as mind mapping, structural calculations, analysis, and also craft by using MATLAB.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. My name is Darius Iskandar, metric number 241-9521, and I'm going to explain about code that calculate our range for tank volume. And as you can see, our code here is started with reinserting the initial value of the tank diameter, tank radius, height, and other dimension. After that, we add also the formula to calculate the volume, which is pi r square times h, and after that we put some restriction where to make sure the tank is the tank volume is increased from 10% to 20% only, and we will make sure that radius is at that range too. And after we get this graph, we have decided to choose 15% increment, because we think that is the most suitable case for this problem solving, because it is the increase is just 15%, and that's not too extreme from the previous module of tank.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Danish Haikal bin Ahmad, metric number 241-9541. Now I will present how to get the weight distribution of the beam of the cylindrical water tank. The first step is to draw the free body diagram to give us a clear visual of all forces that are available. So as you can see on my right, this is the free body diagram. A is a pin, B is a roller, F is the distributed load, D is the length of the cylindrical water tank. For your information, our group increased the volume by 15%. So the height is still same, 16 meter, but the radius is 7.51 meter. So we can get all the information on this diagram by using density formula. Then we can obtain the mass, and the mass we times it with the gravitational force, and then we can gain weight. After that, we divide the weight with the length of the cylindrical water tank, then we obtain the distributed load. And then for the forces at the supporting beam, I only use three equations of equilibrium, which is total moment at A equal to 0, total force at X direction equal to 0, and total force at Y direction equal to 0. So from this calculation, we found that both forces at A and B have equal values and an increase by 30% from the original value of the forces. The original value has radius 7 meter and height 16 meter, and using the same method of the calculation. To conclude, we need to use a suitable material for the supporting beam, considering the stress of the material as well, in order to accommodate the cylindrical water tank due to the changes of the volume. So that's all from me.
Assalamualaikum. My name is Ikhwan Arif bin Halim, metric number 2414229. So I will explain about shear force for this project. Before we jump to the calculation, we need to know first what is shear force. So shear force is a force that acts along a plane within the material, causing one part of the material to slide or shear relative to another. It is typically caused by external loads that are applied perpendicular to a structural member like a beam. So this is a MATLAB code to calculate the shear force. First, we insert all the information such as the length of the beams, which is 15.42 meters, and uniform distributed load, which is 1.84 times 10 to the power of 6 kilonewton per meter. Then we create the x-axis for the beam, which is a linearly spaced vector containing 100 points between 0 to L, length of the beams. This represents the position along the beam where the shear force is calculated. Then we write the equation of shear force and we plot the shear force diagram. So this is the shear force diagram. From this diagram, we can see that the shear force distribution decreases linearly to the length of the beam, and it starts a positive maximum values at one side and transition to a negative maximum value on the opposite end. So that's all my explanation of shear force for this project. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazmi Akmal bin Muhammad Nur Akmal. My matric number is 2412475. And for the last part of this presentation, I will explain about the bending moment. And before we start, we need to first of all, before we start, we need to understand what is bending moment. And to briefly explain to you, the bending moment is a measure on how much structure, or in this case, how much the beam tends to bend when external force is applied to it. And this, for information, this bending moment is one of the critical factor that we as engineers we need to consider for ensuring the safety and the efficiency of a structure. And currently we use the MATLAB, the software called MATLAB for us to calculate the bending moment, and you can read by your own here. And next, this is the MATLAB code, and here you can see that the length of the beam is 15.42 meters, and the W is the distributed uniform load that had been calculated well by our previous presenter just now. Is the W is 1.84 times 10 power of 6 kilonewton meter, and we calculate the bending moment by using the formula bending moment M equal to WLX over 2 minus WX square over 2. And here we get the graph from the code. We get the graph here, and from the graph you can see that the beginning and the ending of the beam, the bending moment is 0. However, in the middle of the beam, the bending moment reach maximum at approximately 5.5 times 10 power of 7 kilonewton meter, which means in the middle of the beam it creates the biggest displacement with the biggest bending moment. It creates biggest displacement from the origin, like this. Okay, that's all from us. That's all from us. Sorry for the inconvenience. That's all. Thank you.